Good morning to all of you. This is Dr. G.P. Pawan, AICTE convener. Today, day 6, session 1, morning session. So this is AICTE sponsored STTP phase 2 under the heading of AICTE heading, Explainable Artificial Intelligence and Machine Learning for Solving Learning Problems using Python and TensorFlow. Today's morning session, Professor T. Vivekanandan, Associate Professor, CSE Department, SITAMS, Chittoor. So our professor will be taking on the topic of machine learning techniques in big data analysis. So how this application of big data analysis by using machine learning features, our sir will be explaining. So before starting the session, I would like to hand over to the our Professor K. Lakshmi Narayan. Lakshmi Narayan sir will invite the Vivekananda sir, honorably resource person of AICTE.
Okay,
sir,
thank you, sir. Okay, thank you, sir. So I am very happy to invite Mr. T. Vivekanandan sir. So he has been working as associate professor in CSE department, SITAMS, Chittoor. He has served as also coordinator for IQAC during 2014 to 19. So he also in charge for the computer center in Srinivasa Institute of Technology and Management Studies, Chittoor. So he has more than 16 years of teaching experience and 2 years of industrial experience. He completed his ME from Anna University and BTech from Madras University. He has published 30 plus papers in various reputed international and national journals and international conferences. He filed for patent on intrusion detection system topic. And he acted as a resource person in various events like AICTE, UGC, and other sponsored workshops, FDPs, and conferences. He is a lifetime member in the Indian Society for Technical Society and the Computer Society of India and IAEMG. And many awards and merits he received. One is in elsewhere published his research work under meritorious paper in Honored Papers 2017. Then he got a Best Paper Award in Second International Conference on Advances in Information Technology and Computing, April 2019. Then he published one book chapter in Springer 2008. And he attended more than 40 events under workshops, FDPs, and industrial trainings. And his areas of interest are predictive analytics, data science, big data analytics, machine learning, and high performance computing and cloud computing. So with this brief introduction about Vivekanandan sir, I am very happy inviting Vivekanandan sir to take over the session and enlighten our participants. Thanking you, sir.
Thank you, sir. Thank you. So first, let me make sure whether my voice is audible, sir.
Yes, sir. Clearly audible, sir.
Fine, sir. I'll be continuing here.
Okay, thank you, sir.
Very good morning to, shall I proceed, sir?
You may proceed, sir. Proceed.
Yes, sir. Thank you. Thank you, sir.
Okay.
Very good morning to all the participants. In the first session, I plan to go with big data analysis and concluding with how machine learning techniques are applied in big data analysis. So first, let me brief about this technology, big data analysis, and then at the end, let me get into machine learning techniques and approaches in big data analysis context. And in the afternoon session, practical on how to go ahead with this big data analysis, and at the end with machine learning techniques. So first, let me come to what is big data and what actually makes data as big data. The one which could not be handled or managed with traditional resources. For example, if you have very large data or highly complex data, if that could not be handled or managed with your traditional resources, Either it may be traditional data processing or it may be traditional storage resources, which is not possible to manage, or if it is inadequate to handle this, then we call that term as big data. So the basic idea here is you have vast amount of data as well as more complex amount of information is available. How you are going to extract and take the knowledge which is hidden behind that is what is that. So big data requires a new architecture, a new techniques, a new algorithm, even a new analytical approaches. The traditional approaches, whichever is existing, could not able to handle this. That is the reason why we are getting into this platform, big data analytics. So three things which we can take out mainly from this. One is massive volume amount of data or massive volume of data, and data which is in complex data formats, and the one which could not be handled using traditional data processing. Collectively, this is what we call it as big data. Now let us quickly have a look on how data is being spreaded up across let's say different applications within 1 minute. So if you quickly look into this, huge amount of data is getting generated from various sources. For example, Facebook is generating huge amount of data. 16 million text messages are being sent within 1 minute. 4.1 million videos are being viewed. So all these informations are recorded, and this is being maintained by them, and by, let's say, that organization is making use of this huge amount of data for further processing and converting that into big business. So this is what is happening with respect to every organization. So this is in Facebook context itself. Within 1 minute, if you look at this, 500 accounts are being added, newly added within a minute, and nearly 50,000 links were being shared. And within a minute, 323 days of YouTube videos are viewed on Facebook. So this is how Facebook is making use of your information. Whatever is being viewed, or let's say whatever you have shared, even the like what you have given, let's say for a particular message in Facebook, is being recorded and it is being used. And nearly $11,700 they are earning within a minute. It's all because of the information which is available with them. And coming to different sources for this big data. Of course, various sources. Data comes from, let's say, social media. Data comes from, let's say, CRM, ERM data, even web data, website data, mobile data. Likewise, different sources are generating huge amount of data, and that is getting into this platform. And that is the reason why we are looking into this area, because huge and complex amount of data is available. How to extract the hidden values from that is a key concern here. So this is a scenario of how data is being scaled from, let us say, small amount of information to huge, and how it is getting into this big data. For example, if you look at this, like ERP and CRM, right? Enterprise resource planning concerned with an organization, and customer relationship management maintained in an organization usually generates the data in terms of megabytes and gigabytes. But once if we enter into web platform, the data which is getting generated is in terms of terabytes, and other applications surrounded by that, if you see, like data generated through sensor devices or mobile devices, or other like video data, audio, let's say SMS, MMS data, whatever is generated around this, or in terms of petabyte. So this is what makes the data as huge data and complex form of data. Of course, this is the source where we get different, let's say, data from different formats as well as more in complex form. Now coming to characteristics of big data. Earlier, only 3 V's has been considered. Means when big data came into picture, only 3 V's has been considered initially. So those 3 V's are velocity, volume, and variety. Volume specifies the amount of data, and variety refers to different formats of data like structured, unstructured, and semi-structured, and so on. And velocity refers to the speed in which data is being generated. The speed in which data is being generated. So this 3V is what is initially considered in the big data platform, and slowly it has been matured with 5V model, like veracity and veracity and value has been newly added to this 3V model. And this 5V model includes those 3 already we discussed, right? Variety, volume, and velocity. In addition to that, value and veracity is being newly added to this platform. Value, which always refers to business perspective, and veracity, which will ensure the trustworthiness and authenticity existing with the data, and also reputation and the original origin of the data. So all this will get ensured. So that term refers to veracity. So this is about 5V model, and this is also getting matured. I mean, this also got matured, and now like 10V model is being in practice, and even people speak about 40Vs also. Near to 40Vs also they are talking in the current term. So beside this 5V that we discussed, like volume, velocity, variety, veracity, and value, other V's like validity, variability, venue, vocabulary, and vagueness. So these are the other V's which are, let's say, being adopted after 5V model. In the present scenario, even the big data industry speaks about nearly 40 V's model. So that is also in let's say discussion. So this 5V and let's say the extended 10V and what I mentioned 40V is all going to represent different characteristics of big data. Now let us look into some of the let's say V model, and we'll get into the next one. So first one is data volume. If you consider between 2009 to 2020, the data is nearly 44 times it has increased within a span of, let's say, 10 years. So 44 times it has increased compared with 2009 and 2020. So hardly less than, let's say, 1.5 year, it is getting doubled. So that is why 44 times it has increased. And nearly from 0.8 zettabytes to 35 zettabytes of content it has increased. And this is exponentially getting increased, and a rapid growth is what we could see right from, let's say, in the context between 2009 to 2020. And data is exponentially increasing day by day. As I said, it is getting doubled within or less than 2 years, it is getting doubled. And big data is, of course, the data is growing much faster than Moore's law. So Moore's law states, let's say, the amount of transistor being embedded in an IC chip is getting doubled in every 18 months. The amount of transistors getting embedded in an IC chip is getting doubled for every 18 months, which means big data is growing much faster, and it is getting double less than 18 months. So which means big data is growing much faster compared with Moore's law. And coming to variety, various formats are, of course, existing. We can't expect only a specific format is being available. Let us say, for example, Data may come in the form of image, may come in the form of text, may come in the form of numerical values, let's say multi-dimensional data formats. Handling that multi-dimensional data format with a traditional resources, let's say either to store in a traditional database or processing with a traditional data processing system, it is highly difficult and impossible. And that is the reason why we are getting into this platform to manage this. And the big data platform which is available could manage variety of data formats. It could be either in the form of text content or in the form of numerical content, image, audio, video, social media data, other multimedia data. It is possible to handle variety of data formats with this particular platform. Not only that, even data either in the form of static as well as dynamic. Even streaming data could be managed and it could be handled very well with this platform. And remember, even single application may generate different data formats. So here is how you are going to extract where the major challenges. And also you need to link all this data together and you have to sync and you have to analyze this. So of course, that is the major challenge with respect to this platform. And coming to velocity, the speed in which the data is generated is what this characteristics represents. As earlier as possible, if you do your analysis, you may get all sort of opportunity. Whenever if any late decision is taken, ultimately you may miss several opportunities. So let me give you one scenario. Let us say in case of e-promotion, based on your current location and your purchase history, let's say the company may target the customers. For example, when you cross a particular location, let's say in a metro city or in other cities, if your location is identified, based on your location, even let's say some nowadays they are offering some vouchers through which you can make your purchase. So on that basis, where customers could be attracted for their companies and purchase could, even sale could get increased. So sharing the location or identifying the location is quite important in this context. If they could identify your current location, and based on that locality, they may try to find out the nearest shops and they try to say like this is offer in this place, by which you can attract the customers and you could improve your sales. So this is how the companies were using this information. So in that case, the speed in which you extract the information and do your analysis is much important. Even let us say this is also being used in another scenario like healthcare monitoring. So sensor devices nowadays are being let's say used with human body to monitor various activities. Abnormal conditions, if it is to be monitored, right, and based on that abnormal conditions, the decisions are to be taken. Timely decisions are very much important whenever if abnormality is existing. Late decisions may cause a loss or maybe difficult to recover. So in that case, this is much important. So this characteristics is very much important in that context. And coming to next V, which is veracity, which refers to uncertainties existing in the data. Maybe noisy information may get included along with your data source. Let's say data source may generate, and let's say noisy content and abnormalities in the data may get included. And that is of course a challenging one. Identifying the uncertainties existing and removing those things of course is a big challenge here. And there is also a case like, for example, data comes to your platform not only in the form of structured content, even unstructured content. For example, a text message sent from, let us say, through some social media. Nowadays, we could see these text messages are not being sent as such like a dictionary words. So they use their own or they use their customized way of sending the messages, short form of those messages. Analyzing such messages is quite a big challenge. Let us say, for example, they may text like HI for hi, and let's say good morning, where they type like GD. So these are the short form of communication taking place in the recent time. You have to develop a complete analytics to understand this and further proceed. So this is a quite major challenge in this. And veracity is a characteristics of big data which could help you to overcome these challenges. And coming to next V, which is value. Any business process, if you consider, it always starts with, let us say, starts and ends with value. Any business use case, if you consider, it always starts and ends with a value. Ultimately, that is what a business company looks, what kind of, let's say, I mean, to what extent they could make the profit. On the available information, how they could convert that into big business. So this is possibly could achieve through this characteristics. And coming to acquisition. So how data is being brought into this platform and how they do analysis and what kind of outcome they generate. So that is what big data acquisition. Now, as I mentioned in the beginning, different sources of data. So different big data sources, let us say, for example, maybe in the form of structured, unstructured, data comes from sensor devices, data comes from multimedia devices, from web devices, data streams, various sources. And data gets generated from these sources could not be handled straight away. So this has to be properly you need to remove and uncertainties existing in that. And that could not be possible straight away. You have to, let's say, clearly do this pre-processing and bring this into the platform. And then you should think about what kind of analysis that you can apply. And further, you have to think on which data should be extracted. And then finally, it gets stored in this data storage. And later on, where you can perform various analysis and you can represent or you can use this for prediction, or you can explore, or you can visualize in the graphs and do your analysis, or you can go for further data modeling and so on. So this is how you can make use of this data. Prior to that, where data is data taken from different sources, or let's say uncertainties existing in that are pre-processed, and then it is being analyzed, and later on it is stored in the data storages, and further it is used for prediction or analysis or any let's say either it may be a predictive analytics, or either it may be applied for even other problems also, like even you can visualize it and make use of that data for further analysis. So this is how it is being used at the later stages. And this is an architectural framework, how it is being used in real-time scenario. So the previous diagram, of course, is being represented here in the form of framework. Data comes from different sources, and these sources, let's say, either it may be in the form of social media data, or multimedia data includes text, video, audio, or even a combination of image and text, like multimodal data, log data, as well as streaming data, right, healthcare data. Likewise, data comes from different sources, and these sources are going to generate vast amount of data, and that should be properly processed and it should be stored. So for that, you have this provisioning model and connectivity considerations through which you can get connected to those sources and bring huge amount of data into your big data platform. And further, at the later stages, for data processing and storage in this platform, you have tools like Hadoop, even Spark in the recent time, and other. Even every company nowadays started developing their own big data platforms. So now you need to have this data injection and integration and processing tools in which you can take this data and do your processing. So once if that is done, then later on in the next layer where you have service layer, where this data managed in this platform is given as a service. And further, this data can be applied for various analysis. Like you can apply text analytics, or let's say streaming analytics, or what kind of analytics you want to apply on that, you can do your analysis here. And in the business model where they apply various intelligence technique and they try to extract the value as much as possible. And at the outer layer where you could see it is being used for end user, let's say, access. So either in the form of visualized graphs, or let's say some form of numerical results, or in which form they require, the output of these analytics will be provided to the end users. So this is how a framework is being adopted for this platform. Now coming to how big data is used in practice. Few use cases let us see. First one is how companies were adopting this to target the customers. So this is one of the biggest challenge, of course, and this platform could help them to, let's say, come out with these challenges. So this platform is better used by the, let's say, companies to understand the customer mindsets in terms of their behaviors and their preferences. In that context, they are adopting this, and they are trying to extend their traditional data set to manage this huge amount of data, as well as different formats of data. And ultimately what they are trying to do is they try to create a predictive models. On that basis, they try to say, let us say if a customer purchase a product X, and a predictive analytics model could predict if the customer purchase the product X, he may also, let's say, go for purchasing the product Y and Z, or what is the combination in which. So likewise, this predictive models could greatly support the companies to understand the behaviors and preferences of the customers. So this is how customers are being targeted. Even you could see that you are getting several offers. So it's all based on your previous purchase history or the recent purchase, whatever you made. On that basis, where they target the customers. In order to optimize their business process where they adopt this, for example, let us consider a scenario. Coming week, Christmas falls and followed by New Year, where business companies, for example, like Amazon, Flipkart, and other online, let's say, companies, may try to think about the customer preferences and their behaviors based on the previous history. On that basis, they could, let's say, or they could predict to what extent they have to maintain the stocks. And in that context, where they try to maintain. Even weather forecast is taking place. So on that basis, whether the purchase may get impact or whether purchase may not get impacted. So this is how they could do some analysis. Prior analysis means predictive models could help them to understand, let's say, not only in the context of, let's say, in a year-end sale or whatever it is, they could understand the scenario, complete scenario, and it helps them to optimize the complete business process. And also in delivery also, what is the best route that they have to choose to deliver the product to the customers. So this is how it helps them to understand, let's say, the scenario and proceed further. And This is another use case where big data is used in practice in healthcare sector. This is very widely used in the recent time. Let's say in order to decode the DNA strings, earlier it takes even days, even months to let's say decode this. But nowadays it is taking place within a minute. This platform allows them to perform huge computing and extract as well as better understand the disease scenario. On that basis, they could able to predict in advance. And even in the hospitals, let's say in the baby unit, let us say, they are using it to monitor, let's say, even premature delivery or even the baby which is in sick. So they are trying to adopt this technology to monitor the activities of the babies in the hospital. And even to record and analyze the heartbeat and breathing pattern, they are adopting this. The interesting thing here is algorithms were available nowadays. They have designed the algorithms and applied in this healthcare domain in big data platform to predict any infections which may appear as a symptom 24 hours earlier, right? So these are certain interesting things where this platform is being used, and several algorithms were being applied for doing this analysis. And this is another interesting area where big data is being used for understanding the performance of a particular player or to improve, let's say, the performance of a particular player. This big data analytics is being used. For example, you might have observed, like, this is widely being used in nowadays in let's say various games, like video analytics is being extensively applied in the sports like cricket, football, even other games, tennis, baseball, and so on, where they incorporate various sensor devices in the sports equipment. On that basis, they could do analysis to which speed the player is hitting the ball, or let's say what is the speed in which the ball is being kicked in football games and so on. So this is how they are extensively using this application for performing various analysis and to improve their games. For example, if you look at the scenario where this is being applied in sports to understand the individual performance of a player. So now if you look at this, you could able to, this is based on the prediction or based on the pattern of that player with respect to his previous games. It is being analyzed that 29% he goes left and 57% he goes right and 14% he goes down the middle. So this is how it is being analyzed with respect to a particular player. So similarly, different, let us say, scenarios we can take. So this is about the hitting pattern of a particular player in cricket game, how this is being applied, so that how the performance in that game could be improved. And this you might be very well, where video analysis is being done on that basis, where they try to plan for the next day game plan can be set. So wherever they did the mistakes in the previous day can be analyzed and can be rectified in the next day's game. So that could, of course, improve their sports performance. So this is how it is being used in this platform. Let's say sports. So you all might be very well aware about this. How let's say batsman's strike rate is being let's say analyzed. So these are some of the examples how it is being applied in this area. And coming to another area, like how this is being applied in science and research. So let's say a physics laboratory is making use of this platform for let's say huge data analysis. In their centers, where they use 65,000 processors to analyze 30 petabytes of data. Just imagine 65,000 processors, 65,000 machines they were using to do their analysis, which is about 30 petabytes of data. And of course, the data which they take for analysis is distributed across 150 data centers. So they make use of this huge data and they are doing their analysis. So this platform is used for such applications. So this is of course that complete platform where huge data analysis is being made. The another area how big data is used in practice is improving the security and law enforcement. So this is very heavily applied in the recent time to improve the security and enabling the law enforcement. Few examples let me mention here. NSA, National Security Agency in USA is making use of this big data platform to foil out the terrorist plot, to locate the terrorist plot where they are using this. NSA is making use of this platform. To detect and prevent the cyber attacks, big data technology is being used at the background. Even police forces are also using this to catch the criminals and also even predict the activities of the criminals. They use this particular platform. And very importantly, credit card companies are extensively using this platform to detect the fraudulent transactions. So what are the transactions where they are making use of this platform to do the analysis and predict who is fraudulent and who is not fraudulent based on the transactions, based on let's say their activities. I request you to one of the participant audio seems to be not in mute state. Fine. The credit card companies are extensively using this nowadays to understand the patterns of the customers with respect to fraudulent transactions. Now let me brief what are the tools that are available, and at the end where I'll be showing you some of the tools which is extensively used for machine learning applications. So this is in general scenario how different tools were used. So different tools were available for big data platform. It's not about only one tool. You have several tools available for different analysis. Collectively, this is referred along with, let's say, when you take in Hadoop, this is collectively called as Hadoop Ecosystems. Now, there are several tools available for MapReduce process. Like Hadoop is there, which is very popularly used open source tool. Other than that, we have Hive, Pig, Cascading, Cascalog, MRJob, Caffeine. These are different tools, and even MapR. When you are quite familiar with R programming, you can use MapR to work with big data platform. Flume, Kafka, Oozie. So these are other tools supporting for MapReduce. And NoSQL database, let us say if you consider like MongoDB, CoffDB, Cassandra, Bigtable, HBase. HBase is part of Hadoop. So these are different NoSQL databases which are being used. And for storage, Hadoop by default supports with HDFS, Hadoop Distributed File System. And cloud storages, if you see S3 from Amazon Cloud Storage. And for servers, let us say EC2, Elastic Cloud Computing from Amazon, Google App Engine, Elastic, Beanstalk. So these are some of the extensively used server for big data platform. And for processing like R, Yahoo Pipes, Mechanical Turk, so Elasticsearch, these are some of the tools available for big data processing. Now, let me list out some of the interesting statistics and facts with respect to big data. So nearly 2.7 zettabytes of data, of course, exist in the universe. Maybe higher than that, but let's say this is in the present scenario. And nearly 235 terabytes of data has been collected, especially by US Library of Congress alone. You see, 235 terabytes they have, and they could do huge analysis from this. And USA has invested nearly 200 billion in big data research projects. IDC estimates that by 2020, business transactions on internet, like business to business or business to consumer will reach about 450 million per day. And Facebook stores, access, and analyze nearly 30 plus petabytes of user generated data. Around 30 plus petabytes they have, especially Facebook. Akamai analyzes nearly 75 million events per day. So this is being analyzed to target and, of course, for better advertisement and to attract the customers. They are making use of this 75 million events per day. Besides that, 94% of Hadoop users perform analytics on large volume of data, which was not possibly earlier. But now 94% of Hadoop users were performing their analysis on huge data. And Walmart handles more than 1 million customer transactions every hour, which is imported nearly 2.5 petabytes of data in their databases. So if you look at this, huge volume of data and variety of data comes into this, and this makes them to use this platform for various analysis. And even let us see some more facts. More than 5 billion people were calling, texting, tweeting, and browsing on mobile phone worldwide. And apart from that, to see, decoding the human genome originally took nearly 10 years to process. That is earlier scenarios, but now it could be achieved in a week, which is very interesting, all because of this particular platform. Let's say if you consider Google was processing only 20,000 terabytes of data in 2008. In 2008, Google was processing only to this extent, 20,000 terabytes alone they processed. But at present, if you see, they have capabilities to process 20 petabytes a day. They have a big data platform, and that helps them. In 2017, Google has not only provided how much of data they store, but beside that, Google processes over 40,000 search queries every second. And these are possible because they have this platform, and like big data platform, they developed it, and they make use of this data, and they could predict and they could extend their environment based on that. 40,000 searches are taking place on in an average for every second, which translates nearly 3.5 billion searches per day and 1.2 trillion searches per year worldwide. You see, all this data are being recorded. They record this, they maintain in their data storage, where they, let's say, use this for further analysis. Ultimately, they convert this and they achieve their goals, let's say, in improving their business. Every information is being used. Largest database, if you consider in the worldwide, AT&T, where huge volume of data in one unique database is, let's say, 12 terabytes. And large number of rows in a unique database is about 1.9 trillion. These are some of the interesting facts. And this platform can be adopted for these scenarios, and they could able to handle this huge variety of data as well as huge volume of data. Now coming to a particular tool which is used for big data analysis is Hadoop. Apache Hadoop is a software framework which is especially used for distributed storage as well as processing. For that, they use the programming model which is MapReduce. MapReduce is a programming model which is used for this processing and for storage where they use HDFS. And it was actually designed to work in a cluster, computer clusters. These clusters will be designed on a commodity hardware, very low cost hardware computers they use to design the clusters on top of which they deploy this Hadoop for big data processing. And it also supports to scale from single server to thousands of machines. And the interesting thing here is they have designed a libraries, huge set of libraries. You need not to bother about the failures taking place in that computer clusters. The libraries itself is designed in such a way to manage this and handle such failures. So you need not to rely on the hardware where the library available in, let's say, Hadoop itself could able to manage and overcome this. And that's why it is highly available and reliable platform. And coming to the modules which are designed here is fundamentally designed to handle the failures and automatically recover from the failures. Two core components you can think of with respect to Apache Hadoop. One is storage and another one is processing. Hadoop distributed file system is used for storage. For processing, MapReduce programming model is used. Beside that, like whatever the components I said, the other two components you could see Hadoop Common, which is the libraries available in Hadoop. And this is a newly added component in version 2. Hadoop version 2, Yarn is newly added, which is yet another resource negotiator, which is used for cluster management and scheduling of the applications in the cluster. So simply resource management purpose, they use this in Hadoop, which is not in version 1, which is newly added in version 2. So this is how Hadoop has evolved right from 2002 to 13. As time is not, let me quickly move to next set of slides. Hadoop is associated with other tools, for example, like Pig, Hive, HBase, Zookeeper, and so on. So several tools is incorporated along with Hadoop for big data processing and analysis. Apache, let's say, for example, default, Hadoop is with Java. Hadoop is built on Java program. Defaultly, Java is supported with Apache Hadoop. But for example, if I'm not a Java programmer, I'm not good in Java, but still I should develop MapReduce application. You have Apache Pig. So if you're good in scripting languages, your choice should be Apache Pig. And Hive, let's say if I'm good in, or I could able to write excellent database queries, I'm good in SQL, then you have a choice here. You can go for Hive. Internally, this Hive engine converts ultimately to MapReduce model, which is in Java. But here on top of which you have an echo component like Hive for SQL based developers. And HBase, this is a part of Hadoop database, supports NoSQL. And Zookeeper, Flume, Scoop. So Scoop and let's say Scoop, whenever if you are about to move your data from database to let's say Hadoop platform, and Hadoop platform to database, you can use Scoop. Mahout for machine learning, let's say machine learning applications. Hadoop, it has Mahout. Beside that, there are other machine learning, let's say, tools available for big data platform. But this Mahout is part of, let's say, Apache. Uzi for workflow management, and Spark, it's a, let's say, advanced big data tool compared with Hadoop, where it runs much faster compared with Apache Hadoop. So likewise, I have listed only very few components. Likewise, you have a number of components which are collectively called as Hadoop ecosystems, which will be deployed on top of Hadoop. Now, this is a, let's say, a pictorial view of this Hadoop ecosystem. Now you can see here the base components. The moment you install Hadoop, you get this base components. HDFS, Yarn, and MapReduce are part of Hadoop. So HDFS is for storage purpose. For resource cluster resource management, from Hadoop version 2, Yarn is supported. MapReduce is for data processing. On top of which, where you can go for these eco components, where you can deploy this on top of which, let's say I said pig for scripting SQL queries. If you are strong, it looks similar to that. Sorry. For workflow management, you have Uzi. For coordination, you have Zookeeper. For management and monitoring, where you have Ambari, Apache Ambari. Scoop to move your data between database and Hadoop platform, and Hadoop platform to database, traditional database like RDBMS, you have the Scoop. For machine learning applications, you have Mahout. Even the latest release 14 was released during October. Still, though it is not extensively being used in the recent time, but still updations is there with respect to Mahout, with respect to latest versions. And HBase, which is part of let's say Hadoop, Apache Hadoop. Internally, it has this HBase. So likewise, you have several eco components. Depends on your requirement, you can bring. So H catalog for table and schema management, you have this. For various purpose, you have different components. You can deploy this on top of Hadoop and you can process. On that requirements, you can bring different tools and you can do your analysis in this big data platform. Now, quickly, let us see what is the difference existing between Hadoop version 1 and 2. So compared with Hadoop 1 and 2, we could see the major inclusion is Yarn, which is not there in version 1. The core components are Hadoop Common, HDFS, and MapReduce. Yarn was not there, but this is actually included in version 2, yet another resource negotiator which is used for cluster management. This is about Yarn. Now, compared with version 2 and version 3, if we see, Hadoop 3 enables to have multiple name node. This is not there actually in the earlier versions. So there will be a name node and secondary name node supporting for that. Whereas in Hadoop version 3, name node, multiple name node concept has been introduced in order to overcome the single node failure. So this is one thing which is majorly being included. And in order to reduce the development time, the concept of Dockers has been included here. And also GPU hardware's Hadoop 3 permits within the cluster. These are some of the newly new features which are included in Hadoop 3. So now let us get into briefly about HDFS, and let us get into the next concept for that. Now let us take one scenario, how this is being analyzed and processed in big data context. Assume that it's a customer, let's say, an application related to customer relationship management, where customers' information are being sent through email. And a team available here who receives this email text, and they have to provide the services based on the email text content. And there is a manager available here who takes care of this entire scenario. And for example, here, manager will try to provide the task how these customer informations are to be handled and managed. He is not going to do that role. Instead, he is going to instruct how this is going to be carried out. how the customer services are to be carried out. On that basis, where they could, let's say, do their analysis for, let's say, refund, or let's say whether return or exchange. So this is how they have to come to a conclusion. So this is how a complete scenario you can think of. So this scenario is what we are going to discuss with respect to storage and processing in Hadoop platform. Now the solution here is to store your data, you can go for Hadoop. So let's say to store huge data, you have HDFS. To process this data in parallel, you have MapReduce programming model. The solution is you can store your data in HDFS that manages huge amount of data in that, as well as different characteristics of data could be managed. Even the characteristics what we discussed could be very well managed with this storage platform. And for analysis, you have MapReduce. And again, after your analysis, if you want to store your result back in HDFS, you can, let's say, store your data back. And once if you get the results, you can later use that for, let's say, visualizing it, or to retrieve your data, you can use this. Now coming to what is HDFS, it is a distributed storage which is designed to handle fault. As I said, right, Hadoop itself is designed with libraries to manage this fault, and it could handle very well. And the another advantage here is you need not to have any specialized hardware. You can use this with a low commodity hardware itself, where you can able to manage and do your, let's say, analysis. Of course, you can deploy your hardware platform. I mean, you can deploy your Hadoop with a low commodity hardware itself. Now, different daemons will be running to manage this entire Hadoop. The first one is name node. Name node is considered as a master node, which runs this, let's say, daemon in that node. And the role of this name node is to coordinate, where it will have only metadata. It will not store any data, only it maintains the meta information about the entire cluster. So name node's role is this. And next one is to have a backup for this, you have secondary name node. For example, if something gets failed with this name node, then there will be a backup for this, which is secondary name node. And coming to next node, which is data node. Data node are considered as a slave nodes, which obeys the instruction of the master nodes. And this is going to store the data, and based on the instruction given by, let us say here, we consider the example what we discussed, like a case study, how email informations are being managed with respect to the customers. Now, let us consider a scenario, 1 gigabyte of data is available for you to analyze. Now, HDFS goes with the concept of dividing that data into blocks. For fast parallel processing, the complete data, 1 GB, will be divided into blocks. So where it splits that input data into blocks. And block size will be 128 MB in later versions, and earlier it is 64 MB. Means in the Hadoop version 1, they're designed to have a block size which is 64. In the later versions, it is 128 MB. So this is how 1 gigabyte of data will be divided into blocks, and it will be stored according to blocks. And this information, of course, will be available in the name node, which maintains the metadata about that. Now let us see here. Machines which are running in the cluster may possibly go down because it runs on a commodity hardware. There is no special hardware being used. So it runs on a commodity hardware. Failures are very common in a commodity hardware. So in order to overcome this, where it is designed in such a way that these blocks are being replicated in order to avoid the loss of data. So by default, where 3 is the replication factor. So 3 copies will be maintained. If something goes wrong with one copy, then ultimately it finds the other copy and replicate it and ensures the availability of the data is, let's say, is ensured in this platform. So that's the reason why replica factor is given 3 by default. You can also configure to increase it, depends on your requirement. But by default, it is 3. Now let us look into the case how this is being loaded and processed. For example, I want to load a block A of, as I said, right, the total size 1 gigabyte will be divided into 8 blocks, each of 128 MB when it is later versions. Earlier it is of 64 MB, so 16 blocks. Now let us consider a case I want to load block A of email text. Then immediately it will approach the name node, and name node will instruct where this has to be loaded. For example, name node will identify the available data nodes and it will instruct. For example, here it has identified that the data should be stored in 1, 3, and 7, means data node 1, data node 3, and data node 7. So once if it is stored, then it updates this information in the name node. And where, let's say, when the file is created, it will be with other informations like when it is accessed, modified, deleted, and so on will be available with respect to that file. And where all these blocks are to be stored, so that will be, let's say, maintained in the name node, so that the entire cluster information will be available in the name node. And further, who has rights to view this or modify this file? That will also be available. And how many files are stored on the cluster? This entire information is going to be available with the name node. So only metadata information. It will not store the data. Instead, it will store only the metadata. Now, as I said, here 1, 3, and 7 has been decided by the name node to place this data. Now, block A with respect to that email text of 1 GB will now be placed here, and another copy will be placed in name node 3, and another copy will be placed in name node 7. So it comes to this. Now consider a case when name node 7 fails. The internal libraries designed in Hadoop itself will replace in another node to ensure the data availability. Now let us try to see how block B is going to get stored. Now this is how the metadata information gets updated with respect to block A. How many blocks and in which node, like 1, 3, 7, block A is being maintained in data node 1, 3, and 7, and other metadata information will be available like this. And with respect to block B, it has decided 2, 6, and 10. So what it will do is it will update that information and place block B in data node 2, 6, and 10. So this is how it pushed that block B to data node 2, 6, and 10. Then further, so this is how the entire blocks will be placed in HDFS and it will be managed, like you can see here. And the complete metadata with respect to this, let's say when you consider about data node 4, name node will have this information that block C and E is available and when it is placed and who has created that and what is the access permission given for that. The entire information about that will be maintained as a metadata in name node. Now this is a sample cluster, Yahoo's 10,000 node cluster, Hadoop cluster. So this is how they maintain a huge cluster in real time, and the data will be maintained in different data nodes like this. Now let us try to understand how the clusters will be managed and maintained. For example, here, every rack will be with some set of nodes. And the job, let's say 5 daemons, right? Like name node, secondary name node, job tracker, task tracker, and data node. I'll repeat again. 5 services defaultly running here. One is name node. To provide a backup for this, secondary name node will be running on. Then third one is data node, and the another two is job tracker and task tracker. Now, it will try to deploy the services across this cluster. For example, in rack 1, let us assume in rack 1, one of the node is nominated as name node, right? One of the node is nominated as name node, and this name node is not going to store any data. Instead, only the metadata information will be stored and maintained in name node. Now, if you look at this, the other nodes here are data nodes, and this is, let's say, managed in rack 1. Then, let's say in rack 2, the backup for this name node will be there as a secondary name node. This is in rack 3. So this is an assumption. See, one of the node, which is secondary name node here, will be the backup. So if something goes wrong with name node, then secondary name node will be replacing as a name node, and it takes care of the entire cluster. Likewise, it maintains the entire set of racks, and these daemons will be deployed. So in order to track the job, where it has job tracker, and to track the task in the data nodes, it has another service called task tracker. And collectively, these nodes are interconnected in the switches, and which is being given as an access to end users. So this is how the entire production cluster will be maintained for managing this big data platform. And in order to ensure whether data node, as I said, there is a chance for failure with respect to nodes in the cluster, because it was built on a commodity hardware, low cost hardware. So there is a chance that a particular node may get failed. So in order to ensure that the data node is alive and it is available in the cluster, for every, it sends a heartbeat message. So it sends a heartbeat message indicating that I'm alive in this particular, let us say, cluster. So where it sends a heartbeat message to name node to ensure that this node is available in the cluster. If this heartbeat message is not sent, then name node will come to know that something wrong with the data node, and it will be replaced in another node. So that also we'll discuss with one scenario. Now let us see. Name node 14 is failed, and this information like heartbeat message has not reached the name node. The name node will come to know that node 14 is failed. It may be due to hardware failure or network failure or any failure in that particular node 14. Now, if you observe this at the background, it has some set of blocks like A and C. Now, immediately name node will come to know that node 14 failed, which includes some blocks, and these blocks will be redistributed by identifying the next best possible node. So all these were internal mechanisms. You need not to bother about this. Internally, libraries were written to manage and handle this. Your job is just to submit and let's say process it. You need not to bother about how this are internally being managed. So Hadoop itself will manage this and handle this quite effectively. Now, as he said, name node will come to know that like A and C is replicas of these blocks, and it is going to miss now. So where it will try to relocate this by identifying the next best possible node. For example, now it will try to find where this A and C is available. It has identified that, let us say, it is available here, for example, in node 1. Then it has also identified that it should be replaced in another node, which is 21. So now rack 5, which consists of this data node 14, is failed. As a result, it has immediately identified that these copies were available in node 1, and it should be pushed to another node, which is 21. So by this, it ensures the availability of the data. Even if the node fails, nothing is going to stop. Instead, it will try to redistribute that to another node and continues to proceed further. And this metadata information will get updated. Like block A and C is now being available with node 21 instead of 14. So this updated information will keep on getting updated in the name node, like you can see here. Now, in order to fetch any information, for example, with respect to a file, let us suppose result.txt is a file name. And if this file consists of 3 blocks, let us say, and these 3 blocks are managed in different data nodes, this entire metadata information is available. Now, once if a client put a request to fetch this result.txt file, then immediately name node will find in which data nodes these blocks are maintained. For example, block A is maintained in these data nodes. Then it will try to extract this information from one of these data nodes. Similarly, blocks B and C. So this is how internally it is designed with a mechanism of reading and let's say storing the files. Now coming to machine learning techniques and machine learning tools which are available for big data analysis. So before that, you try to understand what is machine learning, and then let me brief what are the tools that are presently available for handling this big data with machine learning. So machine learning is a subset of AI or an application of AI which allows you to learn by itself or automatically learning ability will be given for the machine, and that learning ability allows them allows it to gain the experience and let's say perform the action on that. So this is what a basic machine learning is all about. Now you can able to let's say provide input to your mission where your mission can understand the patterns existing in that. On that basis, it's like simply providing training to your mission and making your mission to understand the inputs what you have given. And when you supply any new input for the mission, then mission could able to predict. So this is how the intelligence is given for the mission, and this is what is known as machine learning. So machine learning generally begins with observation with or the patterns existing with your data. So we could give several examples for this, like it could be a direct experience given, or you may provide a set of instructions and make your mission to understand, or you can provide different patterns of input and then make your mission to better understand. So these are the different ways of how you can make your mission to understand. On that basis, when you provide any external input in future, your mission could able to predict or could able to provide, let's say, or an outcome, whatever you have designed. On that basis, it is going to provide the outcome. So the prime aim of machine learning technique is to automatically learn without any human interventions and adjust according to that, or whatever the action defined it should provide. So 3 types of machine learning techniques, and this is also being adopted in big data platform. One is supervised learning. So where these algorithms could make prediction on a given set of samples, but here this type of algorithm works on the basis of the trained class. You have to train your system based on the available class label. So where you have to provide class labels as an input and you have to train your system. So this type of algorithms will take the class labels as an input and you have to train your system accordingly, and your machine could understand the patterns existing in that and it will predict the output. Whereas So these algorithms, some of the popular algorithms under supervised learning or regression, classification, Navy-based model, random forest, neural network, support vector machines, decision tree. So these algorithms were available, of course, with machine learning tools for big data platform. And coming to unsupervised, so the difference here is there will not be any class labels associated for this. The algorithm should learn based on, let's say, the patterns existing. So there won't be any class labels given externally, where it has to understand on its own, and it has to predict or maybe use the, for example, clustering techniques, density estimation, dimensionality reduction are some of the examples for unsupervised learning techniques. So reinforcement is another category where it is based on, let's say, or to improvise the decisions, or to keep on improve the better learning experience, where we can use this reinforcement approaches. It's like getting matured and again looking for the betterment in that, and again getting matured and looking for the betterment in that. So these algorithms will work according to that. Now coming to the tools which are available or being available for this particular platform. So you have several tools for handling big data, of which I have given here some of the tools. So I'm not going to discuss all the tools that are available. Some of the popularly used tools for big data platform. For example, Apache Mahout is one, which is part of even Hadoop. So it's free implementation which supports for distributed and scalable machine learning algorithms in that. Several machine learning algorithms has been already designed and it is available. And this is primarily focused on linear algebras. Number of algorithms were available, ranging from, let's say, supporting for supervised learning, unsupervised learning. So beside that, it also offers other algorithms. Even you can also get support for mathematical problems and statistical problems also. And these offers two major categories of libraries where you can use this, let's say, algorithms, and it was developed in Java and Scala mostly. And several release was existing. This is the latest one, which is 14.1 is the latest release as of October 2020. The H2O is another machine learning tool for big data platform. So this is open source, which is especially designed for parallel processing. Not only that, it also supports for performing various analytics, mathematical problems to be solved. Even machine learning library, several machine learning libraries were supported as an inbuilt in that. Beside that, it also supports for data processing and evaluation tools. The interesting here is you have web user interface. So you need not to stick on to text-based mode. You have web user interface that allows you to get into this through web-based environment and you can perform. So beside H2O, where you can also use other interfaces, it also provides other ML tools as an interface. You can bring Mahout into this. You can also bring mlib libraries into this, Spark mlib libraries into this. And you can also perform various, you can bring several machine learning tools like this. It has provided an interface in this platform. And these are the languages which it offers, and you can develop, of course, you can also make use of the existing libraries supporting for machine learning written in Java, R, Python, and Scale. So beside that, you can also extend and you can explore because it is open source framework. So you can also incorporate your own machine learning algorithms in this and you can explore beside what is available in that platform. So this is another important tool available for big data processing. And the another one is, and very popularly used in the recent time, is Spark MLib. Apache Spark MLib is very widely used for machine learning applications in big data platform. It is a distributed machine learning framework, runs on top of Spark. It's not on Hadoop, it runs on top of Spark. So you should have Spark big data platform instead of Hadoop platform, and you can use this Spark MLib library for performing various machine learning to apply various machine learning techniques. You can use this. Why you should prefer rather than going for Apache Mahout? The answer is here. Almost 9 times it runs faster than Apache Mahout. So that is the reason why your choice could be towards this Spark MLib rather than going for Mahout. Though Mahout is updating its version, but most of the choice is towards Spark MLlib because of this reason. And many ML and statistical algorithms has been already implemented. It's not, let's say, already they have implemented for various categories. For example, you can perform various statistical analysis, and it supports to perform correlation, regression, sampling, hypothesis testing, random data generation. All these were already existing and it is available. And beside that, you can apply, let's say, various machine learning algorithms covering supervised, unsupervised. So for classification and regression, it supports various algorithms. For example, you can perform SVM classification, let's say Navy-based classification, decision tree. So likewise, it supports several algorithms and it is inbuilt already. Beside that, for collaborative filtering, you can use this. Cluster analysis, you can perform popular clustering like k-means clustering. So dimensionality reduction features is there. Feature extraction and transformation functions were also inbuilt in that. Several optimization algorithms were part of it. So you can think of various evolutionary algorithms were also given as a part of the Spark MLib library. So here you can make use of it for various purpose. See, it's all depends on your choice, which tool you are going to use. So based on that, you can, or based on your application requirement, you can bring different machine learning tools and you can perform. So before making use of it, you try to understand what are the features available in that tool and how these tools are to be adopted for your application. So try to have an overview on that, and then you can adopt it. So various applications support, you can use this platform for developing various applications. Let's say when it is supervised learning technique, where you can use it for fraud detection, customer retention, diagnostics, image classification. These are some of the applications where you can apply the supervised learning. And in this tools, whatever I have listed, so I didn't listed all the tools supporting for machine learning in big data platform. I have listed only 3 popularly used tools. So you can use these tools and you can perform your analysis with respect to various applications. So some of the some of the popular applications which has adopted these tools is what I have listed here. And for regression, where you can think of market forecasting, weather forecasting, even advertisements, where you can use it for advertisement predictions. So likewise, you can apply it for various applications. When it comes to unsupervised learning in the focus of dimensionality reduction, where you can go for feature, let's say, elitations, you can use it for visualization, big data visualization. This is one of the major application. And also other resources, I mean, other applications you can go on. When it comes to clustering, target marketing, customer segmentation, recommendation systems. So this is how you can apply machine learning with respect to big data platform. And with respect to reinforcement learning, you can think of applications supporting like robot navigation, real-time decisions, game AI. These are some of the applications which makes use of these algorithms. So these algorithms has been already built and it is available for set of algorithms has been already built. Beside that, when you want to extend it for your application, then you can think of extending it according to your requirements, because open source libraries were available. By making use of it, you can extend it for your applications. Now, let me show one case study what we have attempted with respect to this big data platform, which is diabetic data set. We have taken a diabetic data set, and further, whatever the available samples, we have extended it to large volume. And then, so these are the parameters which we have taken for, which we have taken in that data set. And we further applied in our big data platform, where we noticed that a traditional data processing has taken nearly, let's say, 8+ hours to get the result. So where we generated very massive volume of data with our available data, and that is only to test our approach. We have generated the massive volume because we didn't get any data set that supports for such a huge volume. So we generated our own data set based on the available data, real-time data available with us. We generated a massive volume of data, and we experimented in the big data platform and traditional data platform. So we noticed that big data has taken only, let's say, in terms of minutes, whereas traditional data platform, it took nearly 8+ hours to give the result. So we experimented on varying data size, and we noticed that big data platform has taken only very minimum time. So this is one scenario what we have adopted. I mean, we have implemented. Beside that, we also applied for image. Let's say we have taken vast amount of image and we processed it and we applied our technique. And in all these cases, we noticed that traditional data storages and traditional data processing suffers a lot, whereas big data could able to manage and handle this. So this is one scenario what what we have attempted in our environment. So that's all about from my end. Afternoon, we'll try to get into the tool, how you can use this big data tool and how to start working with this platform. We'll discuss it. Pawan sir.
Hello. Hello.
Hello, sir. Hello.
Yeah.
Any participants?
Any participants? Any queries are there? Please raise the queries. One or two participants.
Participants are requested to
Participants
raise queries, one or
requested to raise queries, one or two queries.
No problem.
Hello, sir.
Yes, sir. Any queries, sir?
Okay, students are have no queries, sir.
Okay. Okay, sir. Any queries from participant side?
Any participants? Any queries are there? So thank you for the morning session. So I request all the participants to join sharp 2 o'clock for the afternoon session. We have demo on analysis. So thank you. Thank you very much, sir. We are closing the session.
Thank you, sir. Thank you.